So let's talk about motion, kinematics, motion. When we talk about motion, a body is said to be in motion when it moves from one place to another. For example, supposing that I'm having a body P at point A. When this body moves through a distance with respect to time to another, I think to any point, let's say P, then you see that the body has been in motion. So now when we talk about motion, what should come in mind is that there should be distance, there should be speed or velocity, and of course, there should be time. Now, let us talk about the type of motion. So as I said that a body is said to be in motion when it moves from one place to another. By the form which it is going to take, we are having types of motion. So types of motion. We have linear motion, we have oscillatory motion, we have random motion, we have circular motion, etc. Now when we talk about linear motion, a linear motion occurs when a body moves in a straight line. For example, the motion of a car in a straight road. That's a linear motion. The next thing that we talk about is oscillatory motion. In oscillatory motion, the body just moves about at a specific direction. For example, it's a simple harmonic motion. It's an oscillatory motion. We also have the random motion. In random motion, the body moves randomly in any direction at any hour. That's called random motion. And we also have circular motion. In circular motion, it means that the body is moving around a fixed point. For example, the motion of a planet around the sun. Now suppose that this is the sun, and then we are having the orbit, alright. We have the orbit, and then planets are moving around the sun. Now, the motion of the planets around the sun is called circular motion. This is because they are moving about a fixed point, which is a distance from the center of the sun. Okay, so now this is a planet. Sorry, so this is the sun, and then this is a planet, let's say Mercury. And then there is the distance with it, and it is moving at a certain speed, and this is called circular motion. So in circular motion, simply the body moves around what a fixed point. Okay, so now in kinematics today, we are come to simply state about linear motion. Linear motion, of course, as I said, that linear motion is any type of motion which takes place in a straight line. So now, as I just made an example, that example of a linear motion is a car moving in a straight road. That's an example of what? A linear motion. Now let us talk about the definition of terms in linear motion. Definition of terms in linear motion. Now, consider a body which moves from point A to point B. Now, what should come in mind is first thing, distance. And it is being denoted by D. Another thing that should come into mind is displacement. Displacement, which is being denoted by what? S. Now, listen to me. So this body moving from point A to point B, it covers what? A distance. However, you have to know that there is a difference between distance and displacement. When you talk about distance, distance is simply the length between 2 points. Whereas the displacement is simply a distance covered by a body. So now what is this? The length between point A and B is called distance. Now, the distance covered by the body from point A to point B is called the displacement of the body. The displacement of the body. So now, of course, simply there's a difference between distance and displacement. Distance is the length between 2 points, whereas displacement is the distance covered by what? By a body. Alright. Now, the next thing that should come into mind is that all motion occurs with respect to time. For example, in linear motion, a body covers a distance from an initial velocity and attains the final velocity with what? With respect to time. So now this, let's say, be the final velocity of the body. So we just move from point A to point B. And as it moves, it covers a distance, and the distance covered is called displacement. And then it is the motion is also with respect to time. Now, let us come to another definition. Let us talk about speed. Now, when we talk about speed simply means distance over time. Speed simply means distance over time. Now, look at this too. We also have another quantity which is called velocity. Now, when we talk about velocity, velocity is the displacement with time. The displacement with time. So, however, there is a difference between velocity and speed. There is a difference between velocity. Difference between velocity and speed. Number one, when we talk about speed, there is a velocity. Speed is a scalar quantity, whereas velocity is a vector quantity. Now, what do I mean by a scalar quantity and a vector quantity? Now, when we talk about a scalar quantity, it means that that particular thing has magnitude but do not have direction. Whereas when we talk about a vector quantity, it means that that particular motion or that particular system has both magnitude and what? Direction. What do I mean? Let's make an example. For example, a body moves with a speed of 20 kilometers per hour. This is scalar quantity. Of course, it can move. Suppose that this is your cardinal point. The body can move in the north, south, and east and west. So now, what you have to understand is that with a scalar quantity, it doesn't have a direction. Whether it is moving due north, due south, west, or east, it does not have what? A direction. All what you need is that the body is moving at a particular speed. But when you talk about the vector quantity, then it means that the motion of the body, it has both magnitude and what? Direction. For example of a vector quantity in terms of velocity is that the velocity of a body is given by 20 kilometers per hour, comma 050 degrees what? 050 degrees what? West. Now, 050 degrees west. Now, what does it mean? What does it mean? What does it mean? In vector quantity, as I said, it has both magnitude and direction. Now, all angles are measured from the north in the clockwise direction, the north to the west. So now, what we're simply talking about means that the body is moving in this direction, where these are 50 degrees angle, and the velocity is what? 20 kilometers per hour. So now, how can it then therefore differentiate between scalar quantity and vector quantity? In a scalar quantity, it has only magnitude, whereas in vector quantity, there is both magnitude and what? Direction. Alright, so now that's the difference between speed and what? Velocity. That's the difference between speed and what? Velocity. One is a scalar quantity, the other one is what? A vector what? Quantity. Now, let us talk about the similarities. The similarities between speed. So this is a similarity. The similarities between speed and what? Velocity. Of course, they are all measured with the same SI unit. They have the same SI unit. That's velocity. The similarity between velocity and speed. Now, look at this. Velocity, the formula for finding velocity is displacement over time. As I said, displacement is the distance covered over time. So now, it is having an SI unit displacement. When you take the dimensions of displacement, you have your length. And length is measured in meters. Time is also measured in what? Seconds. So now the SI unit for velocity is meter per what? Second. Now, So let's talk about speed. The formula for finding speed is distance over time. Distance over time. As I said, distance is the length between 2 points. That is displacement, the distance covered by a body. So now speed is being defined as the distance over time. Now distance is measured in meters, time is also measured in what? Seconds. So now it is also having an SI unit of what? Meter per second. So now this therefore gives a similarity between velocity and what? Speed. That's they have the same what? SI unit. Now let us continue with the definition of time. Now when we talk about velocity, we are actually having two types of velocity. We have initial velocity and a final what? Velocity. Now you notice this. In cars, we are having the accelerator, the clutch, and what? And the brake. Now, of course, the clutch is used for changing gears. The brake is used for retardation. And when we talk about the accelerator is used for increasing speed. Alright. So now, what should come in mind is that accelerator is used for what? Increasing speed. So now, when the body is accelerated, mind you, the speed will not remain the same, but the speed what? Increases. So now, supposing that the body was initially at, let's say, 20 meters per second, when it was accelerated after a certain time, it attained a final velocity of, let's say, 80 meters what? Let's say this is the initial velocity. So initial velocity is the former speed of the body as it is being directed towards you. After it has been accelerated after a certain time, it is going to attain a certain what? Higher velocity. Now, the higher velocity attained by the body is called the final what? Final velocity. So now, final velocity is directed towards V. So, acceleration is therefore defined as the time rate of changing velocity. Acceleration is defined as the time rate of changing what? Velocity. Why? This is because when a body is accelerated, it is going to move from a lower velocity and then attain to what? A final velocity after what? A certain time. Okay. So now the formula for finding acceleration is A is equal to V minus U all over T. Acceleration is simply defined as the time rate of changing what? Velocity. That is the final velocity attained by the body minus the initial velocity all over the time taken within which the action took place. So, as being illustrated, suppose that this is a straight line, of course, we are talking about a straight line what? Motion. So, this is my point A, my point B, this is my body B, formally moving with a lower velocity, let's say 20 meters per second. And then, now, after the body has been accelerated, it attains a higher velocity, and that velocity attained is called final velocity. So now, it attains a final velocity, which is the higher velocity, this is V is equal to 80 meters per second. Now, the time from which the action took place is, let's say, T is equal to 5 seconds. Then, how do we calculate the acceleration? From A is equal to V minus U all over T. We are having A to be equal to 80 minus 20 all over what? 5. So now, A is equal to 80 minus 20, so 60. 60 divided by 5, of course, when it cancels, you're having what? 12 meters what? 12 meters per second squared. This is therefore the acceleration. Now, derivation of the equation. The derivation of equations. So now, in linear motion now, we are now come to derive the equations or the formula of motion. So now, from A is equal to V minus U all over T, what is the final velocity? This is the initial velocity and this is the time. When we make the final velocity the subject, We are having AT is equal to V minus U. Make V the subject. We have V is equal to AT plus what? Plus U, equation 1. That's our first equation. Okay. Now, consider a body which moves from an initial velocity u and attains a final velocity v with time t through a distance x. What am I trying to write? We are saying that consider a body which moves from an initial velocity u and attains to a final velocity v through a distance what x. Look at it. Look at this. Of course, consider a body which moves from a lower velocity, which is the initial velocity u, and attains to a final velocity through a certain distance with a time. Now, average velocity. Average velocity is equal to v plus u all over 2. Equation 1. Are you here? But we all know that the formula for finding velocity is distance covered over what? Over time, which is the displacement, which is distance covered over time. Now, this is being denoted by equation 2. Now, this is velocity, this is velocity. Now, equating equation 1 and equation 2, what do we have? We have v plus u all over 2 is equal to s all over t. Change of subject comes in over here. It implies that we have s is equal to v plus u all over 2 times t. Now, this is the same as s is equal to v plus u all over 2 what? T. Let me call this equation A. Sorry, let me call this one equation B. Equation A, and this one rather equation B. Okay. Now watch here. From this equation, but V is equal to AT plus U. Is that not it? What is equation what? Equation A. Now, put equation A into equation B. Equation A into equation B. So now this is going to what? S is equal to what? Now, this is V plus U over 2, right? But V is equal to 80 plus U. Is that not it? So now put this in place of the V. We have 80 plus U all over 2 T. Is that not it? Alright. Let us simplify. We have S is equal to, we have 80. Now what is U plus U is what? 2U, right? Plus 2U all over 2 T. Let us continue. Simplifying further, we have S is equal to 80 over 2 plus 2U over 2 all what? T. Look at it. The denominator is the same. So it's like just reversing it. Now, let us continue. Now, you know, S is equal to, but you know that 80 over 2 is the same as half. It's equal to half 80. Now, over here, the 2 cancels out. 80 plus U, T. Multiplying 2 by T. We have S is equal to half AT squared plus what? UT. Are you there? This is the order, the sequential order of the derivation of the third equation. So now let me call this one my equation what? Equation C. Let us derive for the other equation of motion, which is v squared is equal to u squared plus 2s. We are coming to derive it. Now, from you know that we just took the average of velocity. That average velocity is equal to the sum of the initial velocity and the final velocity all over 2. But velocity is equal to the displacement over time, so just equate, which is s over t to v plus u all over 2. Then you have s is equal to v plus u all over 2t. Yes, alright. But acceleration is the time rate of change in velocity, which is v minus u all over t. Final velocity minus the initial velocity over time. Making time the subject over here, we have t is equal to v minus u all over a. That's, let me take time to simplify it. From a is equal to v minus u all over t, we have at is equal to v minus what? All over u, right? So now it implies that t is equal to v minus u all over a, and that is what we have over here. Okay. Alright. So now, put t is equal to v minus u all over a into equation b. Into this. We have s is equal to v plus u all over 2 times the t multiplying the denominator, which is 2 times a, we have 2a. Now, multiplying and simplifying, we have v times, which is what? V squared. V times minus u, we have minus ub. And then u times v is what? Positive ub. This times this, which is u times minus u is what? Minus u squared. Remember multiplication of algebra. Simplifying, the minus u shall cancel the positive u. Now, when they cancel, then we simplify, then we have 2a is equal to v squared plus what? U squared. Make v squared subject. We have v squared is equal to 2as plus what? Plus u squared. Alright. Now, this is another formula. Let me call this one equation what? Equation C. And this formula is connecting final velocity to acceleration, the displacement, and the initial velocity without what? Without time. Okay, so now kindly just come here. We are having v is equal to at plus u. Now this is used for calculating any of the quantities when one is not given. Suppose that we have v is equal to at plus u. You can use this formula to calculate for acceleration by making acceleration the subject. You can calculate time by making time the subject. Over here we have s equal to v plus u over 2t. Now you are going to observe that over here there is no acceleration. So now this best fits from when final velocity, initial velocity, and then time is given, and you are asked to calculate for the distance what's covered. So you have another formula for distance, which is connecting acceleration, time, and what? Initial velocity, which is s equal to half at squared plus ut. And then we have another final formula, which is v squared is equal to u squared plus what? 2as. And this is connecting initial velocity, acceleration, and what? The distance. So now, whenever any question is given, depending on the parameters available, then you have to know the formula that you have to use. So now, let us take an example. A body moves from an initial velocity of 10 meters per second. If accelerated at 4 meters per second squared for 10 seconds, calculate the final velocity attained by the body. So, first of all, in order for you to see it understanding, let it illustrate it. So now, what it simply means that this point A, then this was my point B. Okay. Now, your father's car, which is let's say a body B, was actually moving with an initial velocity of what? U. Now, note this, that a body moves with an initial velocity. So it means that the velocity with which the body was moving before it was what? It was accelerated to attain the final velocity. Is that not it? Now, you know that the initial velocity is being denoted by what? By u. Okay, so now u is the initial velocity. That's actually speed that goes track. As our call by accelerated car. Okay, speed that now body all of that, which is the initial. It was what? 10 meter what? Per second. Now, after it was accelerating with what? So calculate what? After it was accelerated by 4 meter per second squared. Is that not it? So now A is what 4 meter per second squared. So now we have to calculate for the higher velocity, which is the final velocity v. And this is not known. So now your father accelerated his car at 4 meter per second squared after a time of what? 10 seconds. Calculate the final velocity. So now, what do? Write down the parameters first. V is equal to 10 meter per second. T is equal to 10 seconds. We don't know v, but acceleration was what given. Now, after that, then you come into your equations. Which one best fit for the question given? Now look at this. You have v is equal to at plus u, and you have all this formula. Look at this. Initial velocity is given. Time is given. You are asked to find for the final velocity, whereas acceleration is what's given. So now over here we are come to find for what? Final velocity. So we cannot use this formula because no distance was given. Moreover, we are asked to find for the final velocity v. These do not contain v. Is that not it? Now let us go over here. We are asked to find for what? The final velocity, but acceleration was given. Over here there is no a, there is no acceleration, so it means that you cannot use this formula. Is that not it? Now, over here we have the final velocity over here, alright? We have the initial velocity. We are asked to calculate for what? Acceleration. But the distance was not given. Is that not it? Distance was not given. So it means that you cannot use this formula. So now the best formula that suits this question is using the first one, the first equation, which is v is equal to at plus what? At plus u. So now, from v is equal to at plus what? U. Okay. We have v, which is the final velocity, is equal to acceleration, which is what? 4 times the time, which is what? 10 plus the initial velocity. And what is the initial velocity? 10. So now v is equal to 40 plus what? 50. V is equal to 90 meters per second. Are you okay? So now the father has accelerated his car for 4 meters per second squared from an initial velocity of 10 meters per second. After 10 seconds, it is going to attain a further velocity of 90 meters per second. And this is kinematics, mechanics. Now, let us come here. A body moves from rest with an acceleration of 6 meters per second squared. Calculate the distance covered afterwards after 9 seconds. Now, what you have to note is that when a body moves from rest, u is what? 0. When a body moves from rest, the initial velocity is what? 0. Now look at this. This is my initial state. And I'm now moving. Is that not it? So now, as I move, I'm going to attain a certain final velocity after a certain time. Now look at this. Initial velocity is the velocity of the body before it was what? Accelerated to increase in velocity. So now, when a body moves from rest, therefore, the initial velocity is 0 because initially it was at rest. And when the body is at rest, it has no speed. Is that not it? So now, illustrate this. So now, the initial velocity is what? Is 0. Now, they are saying that it was accelerated with what? So now, v is equal to 0. It was accelerated with what? At what? 6 meters per second squared. Is that not it? Now, what parameter again was given? Oh, you were given time, which is what? 9 seconds. And what are we asked to calculate for? We have to calculate for what the distance was covered afterwards 9 seconds. Now, the distance covered, which is the displacement, so it is being a simple s, is what is not known. So we have initial velocity, which is given, which is 0. Acceleration is 6 meters per second squared. T is equal to 9 seconds. The distance covered is not known. So we are come to look for an equation which connects initial velocity, acceleration, time, and what? Distance. Okay, so now let us come over here. Let's come over here. Now let us look for equation which connects distance, initial velocity, acceleration, and what? Time. Okay, this formula is not used for calculating for distance, so it does not suit. Okay. Um, of course, as you can see, we are having displacement over here, right? So let me see if you can, let me analyze if you can use this formula. Okay, but final velocity will not give you. You have to calculate for this, but this will not give you, so it does not match. But let us come over here. Acceleration is given, which is 6 meters per second squared. Over here, there is no what? Quantity of acceleration, so this cannot be used. But let us look at this. We have initial velocity, which is 0, right? We also have the time present over here. And we are having the acceleration. And we have the dimension for distance. Of course, then we can use this one. So this is the formula which best suits. So let us apply this formula. S is equal to half AT squared plus UT, comma. S is equal to what? Half what? What is the A? 6, right? Time is what? 9. Plus U is what? 0. So put 0 by here. And 0 times, so the time is what? 9, right? Good. Sorry. Okay. So now, 2 cancels 6 how many times? 3 times. Now, we are having S is equal to 3 times 9 squared. Now, what is 0 times 9? 0, right? So, plus 0. Now, what is 9 squared? 9 squared is what? 81. 9 times 9 is 81. So now we are having S is equal to 3 times what? 81. And this is going to the distance covered, right? So now, 81 times what? Times 3. 31. So this was 24, right? Okay. So it implies that the final distance covered is what? 200 and what? 43 what? Meters. You know that distance is measured in what? It's measured in meters. So now the distance covered is going to what? 200 and what? 43 what? Meters. Okay. So let us come to the last question. Determine the final speed attained by a body which attains 60 meters per second from 25 meters per second with an acceleration of what? 7 meters per second what? Per second square. Okay, so now we have to determine for what? The final speed, right? This is the final velocity. Okay, so it should be final velocity. So now V is not known, attained by a body which attains 60 meters per what? Oh, sorry. Alright, so sorry for the question. The actual question is determine the final velocity attained by a body which moves from 50 meters per second through a distance of 180 meters with an acceleration of what? 3 meters per second squared. Okay, so now over here we have to what? Calculate for the final velocity V, right? It's not given. Attained by a body which moves from so what's the initial velocity? 50 meters per second. Through a distance of what? 180 what? Meters with an acceleration of what? 3 meters per second squared. Okay, so now you just look through the four formula, which is V is equal to AT plus U, S is equal to B plus U all over 2T, S is equal to half AT squared plus UT, and V squared is equal to U squared plus 2AX. Ask yourself the question, which one of these formula best fit? Now, from this, we are going to observe that the formula that comprises of all these parameters is V squared is equal to U squared plus 2AX. So we are asked to find for the final velocity, is that not it? So now what do you have to do? You have to make the final velocity the subject. So now it implies that V is equal to the square root. Of course, you know. Do you know why? This is because, look at this. To make the subject over here, then you have to take off the what? the 2 over a. Is that not it? So now we have v squared is equal to, just put this into brackets, u squared plus what 2as. Is that not it? So now just multiply this by half, just multiply both sides of the equation by the same ratio. Alright, so half half, is that not it? So that this half shall cancel the 2, so that we have v is equal to u squared plus what 2as exponent half. But I know that any variable or any value which raised to the power half is the same as what? Square root. Is that not it? So now it implies that v is equal to the square root of u squared plus what? 2as. Now you substitute. So you have v is equal to the square root. What is u? 15 squared plus 2 times acceleration, which is what? 3, right? Times the distance, 180. Of course, as you can see, I'm not a machine. I have to use a calculator. So just punching everything directly on my calculator. I have 15 squared, no senior square, use calculator, right? Right. Plus 2 times 3 times what? 180. And the final answer is what? 36.125 meters per second. Which is 36.125 meters per second. Okay, so now this brings us to the end of the part 1 of what? Motion. So of course we started with some simple definition: distance, displacement, acceleration, initial velocity, final velocity. Of course you also learned about the types of motion, and then this came to conclude with the derivation of what? The four formula of motion, which is v is equal to at plus u, s equal to v plus u all over 2 times t, and then you also have s equal to half at squared plus ut, and then v squared is equal to u squared plus 2as. And of course, remember that whenever a problem is given, depending on the parameters available, then that is going to tell you the type of formula or the formula that you should use. So of course, just came here, the body moves with an initial velocity. So it moves with what? An initial velocity of what? 10 meters per second. So initial velocity is what? 10 meters per second. And it was accelerated to attain a certain higher velocity, but it was not given. So you have to calculate for that, a certain higher velocity, after further accelerated the car at 1 meter per second squared at a time of what? 10 seconds. So you have 90 meters per second. Over here, you still have the same. Due to the question given and the parameters available, we are asked to calculate for distance. This formula best fits. So you have 243 meters, and of course, you also have this. Thank you very much. So this brings us to the end of the part 1 of linear motion under mechanics. Thank you.